And we left off asking questions about ions. So the very first question we're coming up on is number 8 on your PowerPoint. So I am going to present that to you. Hold on, let me pull up the PowerPoint on my screen. And hold on, guys. I have like so many bars and windows open. All right, let me stop my share. Hold on, let me get to the slide I want to be on. Oh, come on, come on, come on. I'm getting there, almost there. Okay. All right, I'm going to stop that share and I'm going to start, no, this share. Can you guys see the question on the screen? Our answer for this question is magnesium. We're looking at the magnesium cation. So the answer is B. And mind you, if the answers are not marking correct for you right now, don't worry about it. That's something that I can always change later. I made these questions the other day when my brain was super, super fuzzy. So if the answers are not correct, don't worry about it. That's something that I can review later on. So how do we know? First off, we have to know where magnesium, what the symbol is for magnesium, which is Mg. As an atom, it has 12 protons and 12 electrons. And it's going to lose 2 electrons. So it now ends up having a +2 charge. Why? Because I have 12 protons and 10 electrons. All right. Nope. Mg and Mn is not the same. Make sure you're using your periodic table, right? And the charge is plus. So notice how we always write the charge. So it's always the number, then the sign, right? It's never the sign, then the number. So it's always the number, then the sign. All right, we got another question coming up. So make sure that you are using your periodic table, and the atomic number tells you the number of electrons in an atom, right? And if we're talking about a phosphide ion, which now has 3 additional electrons, all you do is add that number to the atomic number to determine the number of electrons that it has. And our answer is D. If we are looking at phosphorus, it has, its number is 15. So it has 15 protons, and 15 electrons. And it's going to gain 3 electrons. So we end up with phosphide. Oh, that should not say 12. That should say 15. That should say 15 electrons and 15 protons. Okay. All right, so now we're going to do some practice on explaining the formation of anions and cations based on the periodic table. So you are going to, so these questions are related to electron, not electron, they're related to ionization energy. So you're going to answer this question based on what you know about ionization energy, right? We know that as we go down the periodic table, ionization energy decreases, and as we go across the periodic table to the right, ionization energy increases. And mainly it's due to the due to the number of protons being added and the attraction between those electrons. And the more you fill up an orbital, the harder it is to pull those electrons away from each other. So, all right, the question is being presented to you right now. Remember, ionization energy increases as you go across the periodic table to the right. So atoms that are all the way on the right-hand side of the periodic table have a really hard time losing electrons. So one of these answered, or two of these answered choices should not, you should be able to cross them off, because they are to the far right of the periodic table. So check your answer. So let's take a look at what the answer is. Our answer is sodium. Why is it sodium and not calcium? Anybody want to explain? Raise your hand and I'll unmute you. Anyone want to explain why the answer is sodium and not calcium? Go ahead, Jacob.
It's more to the left on the periodic table.
Yes, it's more to the left on the periodic table. Even though it's lower on the periodic table, remember we said as we add more electrons. Do you have, you want something to add, Carlos?
I was gonna say, because every, like, you know, they want to have a full valence shell. So since it has one, it's much easier to just take that one off than two.
Absolutely, it's much easier. Now, the one thing that you should know is that electrons get pulled away one at a time, right? And you know how they have that saying, 2 peas in a pod? When you have 2 peas in a pod, can you ever separate 2 little children that people call, or 2 friends that are 2 peas in a pod? Yes or no? It's hard to separate 2 peas in a pod, right? So if we've got, calcium has got, has a 2s, has 2 s electrons, whereas sodium only has 1 s electron. So it's harder to pull that P out of the pod than it would be in sodium. Let me check the chat right quick. Okay, cool. Yes, Kelly Lau, you are right. Yes, and alkali metals most easily lose electrons. Yes, you guys are good. Yes, there's powers and numbers. All right. All right. Let's see what's up next. We've got one more in this series. And let's see how you guys do on this one. So it's related to our last question. Now remember, the question is saying increasing ionization energy. So you start with the one that has the lowest, then go to the highest. Lowest to highest. All right, so the answer to this question is going to be B, because increasing ionization energy, we're starting with the one that's least, which would be rubidium, then potassium, then sodium and lithium. So you have to look at the periodic table, okay? Good job. Thinking, putting those brains to work. That's right. So these guys are all in the same group, and the ionization energy increases as we go up the column. All right, so now we're going to practice determining the formula of the compounds based on the charges of the anions. So if we were to write the formula for potassium chloride, remember they both have a 1 charge, so there's no subscripts for the that formula. Potassium has a +1. Sulfur has a -2. So we are going to swap out charges to make the formula K2S. For potassium phosphide, or potassium phosphide, we know that potassium has a +1 charge, phosphorus has a -3 charge, and we swap out those charges. Notice that for we don't write a 1 when the subscript is 1. So calcium chloride, we have to add a 2 because for the chlorine, because calcium has a +2 charge and chlorine has a -1 charge. Now for calcium sulfate, or sorry, sulfide, we're gonna swap out those charges, but notice that because they're equal charges, we're just gonna write calcium sulfide. For the last one, here's where we're really looking at swapping out charges. We notice that we have a +2 for calcium and a 3- for phosphide. We swap out those 2 charges to give us the subscripts. Calcium should have a 3 subscript, and phosphide is going to have a 2 subscript. How did you guys do? Did you do all right? All right, let's do some more practice. Very top one, at the top it says, write the ionic formula for the compound formed between magnesium and chloride ions. Being that we have a +2 charge on magnesium, that means that the chlorine gets the second subscript, because why? Chlorine has a -1 charge. So number 1, let's see, Katerina, are you correct? No, number 1 didn't appear. So your answer should be B, A, and C. Katerina, you are the winner. So some of you are still not quite sure how this goes. So if I have, let's look at number 2, Al 3+, and I have Br-. The charge swaps. So that's a 1-, right? So I would get Al Br3. Let's look at the last one. I have Ca 2+ and N 3-. We're going to swap that 3 and swap out the 2. So we get Ca 3 and 2. All right. Manisha, I'm not sure what you mean. All right, so it felt like a foreign language on Monday, Brad, but today it's clicking. Yes, chemistry is that thing that you got to look at it over and over and over and over and over and over and over again in order to get it correct. And I get how to do it, just not why. Why? Because, all right, so if I have an aluminum and it's got a +3 charge, so it has a 3+, right? And I have bromine and it has a -1 charge. When they come together, I've got that's an Al. I got an aluminum, right? And it's got a 3+, and I've got bromine, and it's a -, right? Remember, every compound has to be neutral. So in order for these ions to come together and make a neutral compound, if I have Al 3+ and I have 1 bromine, that only cancels out one of my positive charges, and this thing still has, totally together, it would have a 2+ charge. So if I add an additional bromine, right? I've got a 3+, and that's a minus and a minus. This whole thing still has a +1 charge. But now if I have aluminum and I have Br-, Br-, and I have another Br-, now this whole thing has a 0 charge. And that's why we now have a we now have a neutral compound. So this is why, can we do the same crisscross thing when identifying the charge of an element in a formula? Yes, you can. All right, let's see. Okay. So we haven't gone over the dipole thing yet, so I don't expect you to get it just yet. It's something that you've got to look at over and over again. And if you haven't watched a video, then you probably still don't get it. If you, so make sure you watch a video or two, and that should help you out quite a bit. All right, here we go. Now let's take a look. Oh, what do you mean only 17 minutes of battery life? Hold on, y'all, I got to plug in. You can't drop out. All right, so let's look at the answer. So I need to see my screen. The answer is B and Y. If we look at what we have on our periodic table, A is going to be in group 3A, and B is going to be in group 6A, right? So the first element is going to have a +3 charge. The second element is going to have a -2 charge. Oops, and when we swap out the charges, A would have a 2 and B would have a 3 subscript. Let's see, are we going to do this one? No, I'm not going to do that one right now. All right, so how do we write formulas for ionic compounds containing polyatomic ions? It's the exact same thing. But the difference is you have to know the polyatomic ion. You've got to know it. You've got to know it and the charge. So you should know the formula for the polyatomic ion and the charge that it has, along with its name. Okay, so magnesium and the nitrate ion, NO3-. So we're going to swap out the charges, and notice that we have to write a parentheses around the number of the polyatomic ion, right? So NO3 is the polyatomic ion, and then we write the parentheses to say that I need 2 of these in order to put the 2 around it. All right, so let's try this practice on TopHat again. This is another one of those heat questions. Well, let's go over this answer together. I closed out the question. All right, so let's take a look. The answer for A is C. Why? Because aluminum, hold on. Aluminum has a 3+ charge and nitrate has a 3- charge. So we have to swap out those charges, and when we get 3 nitrate ions. So the list of polyatomic ions is in the PowerPoint, in Unit 4.1 PowerPoint. So make sure you go back there and take it. This tells us this is the copper 2 ion. So that means that it's Cu2+, and we're using nitrate again. So we swap out those charges and we get B. The next one is C. Why? Because we're told that we have the iron 3, so it's Fe3+, and hydroxide is a -1. So we're going to swap out those charges and we get C. And for the very last one, once again, we're told that we have the tin 4+, and we have hydroxide, which is a -. So we're going to swap out those charges and we get A. So tin is SN. If you're looking like, what is SN? It's 10. All right. So how would we write the formula for ammonium bicarbonate? Well, first you've got to know what ammonium is. If you look back on the chart back in Unit 4.1 when we were talking about ions, the chart is there, and I will post the answers today. Well, they'll be posted tomorrow, so you can see the ones that you should know, but Memorize that chart. And bicarbonate is HCO3. So, all right, a lot of you have gotten this correct. We get NH4, HCO3. Now, yes, Katerina, make sure your hydrogens are capitalized because it makes a difference. How will we write the formula for calcium phosphate? No, these fingers. Calcium is 2 plus. Phosphate is PO4 3 minus. We swap out the charges and we get calcium 3, phosphate 2. No, so we don't put we put the parentheses around the polyatomic ion. There's no need to put a parentheses around the calcium because it's not a bunch of atoms together. So the reason for the parentheses is to say that this group of atoms, I have 2 of them. So that's the reason. Would it be correct if we wrote NH5CO3? No, it would not be correct because NH4 is its own entity and HCO3 is its own entity. And so they have to be written separately. Does that help you out, Olivia? You have to write the formula for each entity on its own. I am going to skip the next question. The answer would be NH4 PO, NH4 3. Why? Because ammonium is NH4 plus and phosphate is PO4 3 minus, right? And we're going to swap out the charges. And we haven't seen one like this before. So you have to make sure that each entity has its own given number, right? I don't need to write a parentheses around the PO4 because it's only one of them, only if I needed to have more of them. Thank you, Scott, for posting that picture. You guys can download that. Scott posted in the chat for you there. Let me erase my crap that I put on here earlier. So NH4 plus PO3 minus, they're gonna swap out their charges and we have to have the 3 in between, all right? So that is the end of Unit 4, Part 1. All right, so we're gonna take a look at the second half of Unit 4. And let's take a look at the first set of learning objectives, predicting the number of covalent bonds an atom will form based on its position in the periodic table. Now, on this slide, we are asked, can these molecules exist, right? And based on what we know from the periodic table, right, we know that things that are in group 1A, they can make 1 bond.
Miss, we can only see the title page.
Okay, only the title page. Let's go back.
Okay, now you're good.
All right, now we're good? All right. Oops, I swapped the wrong thing. Hold on. I can't see what I'm doing. Okay. All right, so group 1A can only have 1 bond. 2A can only have 2 bonds, right? If we're looking at group 4, they can make 4 bonds, right? If I'm in 6A, it can make 2 bonds, and 7A can only make 1 bond. So if we're looking at this very first compound, CBr3, now, if it can make a certain number of bonds, in order for it to be a happy element, it must make all of those bonds so that the valence shell is full. So if there are not enough bonds, then it's not an actual compound. So let's take a look at the very first one. What do you guys think? Do you think that A is an actual molecule? Yes or no? Yell it out.
Yes.
Let's take a look and see. So carbon needs how many bonds? What group is carbon in? Carbon is in group what? Is in group 4A.
Four.
Bromine is in group 7. It can make 1 bond. Carbon is in group 4. It has to make 4 bonds to be a happy camper. Can A be a likely molecule? Each bromine is making 1 bond, right? But is the carbon making 4 bonds?
No.
No, so this cannot be a molecule. What about B? Iodine can make 1 bond. And how many bonds can chlorine make? How many, folks? 1. So can this be a compound? ICl?
Yes.
Yes, because each of them has the bond that they need. Let's take a look at C. How many bonds can fluorine make? It can only make 1 bond. What about hydrogen? How many bonds can hydrogen make? 1. So is this a possible compound with fluorine attached to 4 hydrogens? Is this possible?
No.
No.
No, no, not at all. All right, let's look at the last one. Sulfur, H2S. Sulfur is in what group? Anybody know?
6A.
6A. How many bonds can it make?
2.
Absolutely, it can make 2 bonds. What about hydrogen?
1.
It can only make 1 bond. So is this a possible compound? Is
Yes.
sulfur happy with 2 bonds? Yes. Hydrogen is happy with 2 bonds. Let's see. All right, that's my time, folks. It's 11 o'clock. So on next week, Thursday, we are going to continue on with these practice problems.